Record thing again. So the main gist of this chapter is to talk about the fact that not all goods have the same kind of responsiveness. So what do I mean by this? So let's go ahead and let's draw a couple different curves, and maybe a little bit straighter than that. So let's go ahead and draw a demand curve. Draw one actually. That looks something like this. So a relatively shallow demand curve. And let's take a look at, let's literally just say that these are all 1. So 1, 2, 3, 4, 5, 6. So from 5 to 6. When there's an increase in the price from 5 to 6, we see that if the demand curve is relatively flat, there ends up being a larger quantity shift, right? The quantity shift 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 goes from something like 11 to something like 8.5. So we go up by 1, but we actually lose, 2.5. Compare this to a demand curve that is relatively steep. Same kind of shift in prices from 5 to 6. Results in a loss of quantity from 5.5 to 5.25, right? Barely anything. So the steepness of the curve tells us about the responsiveness to prices that the consumers in that market have. So the flatter the demand, the more what we're going to call elastic the response is. So let's go into some lecture notes and definitions. So elasticity of demand measures how much the quantity demand changes given a change in the price or a change in consumers' incomes or a change in the price of a related product. What kind of related product? A complement or a substitute, right? So this is a concept that also applies to supply. So we're going to talk about both this elasticity of demand and elasticity of supply. But we're going to focus on elasticity of demand, at least for the moment. And right now we're going to focus on price elasticity of demand. So we already know, right, the law of demand already tells us that if the price decreases, the quantity demanded is going to increase. But the question is, by how much? So the degree of the sensitivity or responsiveness is measured by this thing, the elasticity of demand. Let's go ahead and talk about the formula. So you'll often see this as this like fancy curly Q E, or in the book it's just a capitalized E that's italicized, but I can't freehand italicization very well. And the formula for this is we're always going to have a numerator and the denominator. And I can tell you right now, one of the things to keep in mind is that the thing that's on the numerator is always the quantity. So the percentage change in the quantity demanded. The thing on the denominator is going to change as we get to other types of elasticities. But so this delta here means change. And we're going to unpack this in a second. What does this mean, percentage change? Because there's a way that we used to calculate percentage change, and then we're going to use a midpoint formula instead of using our traditional method. And then on the denominator, who wants to tell me what's on the denominator? Sarah. Huh? Okay. So this is telling us the responsiveness of the quantity to what? To price. So our percentage change of quantity is on the numerator here, and our percentage change in price is on the denominator. So it's telling us how much are consumers decreasing their consumption if the price increases. So if the price of salt were to increase, like how much is salt? How much is a thing of Morton salt? It's like $1.20 or something, right? So if the price of salt were to increase by, 20 cents or something, would you care? Would you notice? You'd still buy the salt. But if the same percentage increase happened to something that was like $100 or $1,000, right? Then you would care. And so the scale of it is really what we're trying to control for here. So we're looking at the percentage change. And so what does this mean when we talk about percentage change? So let's unpack this a little bit more. So any kind of percentage change is equal to my new value minus my old value. And here's where it gets a little screwy, because we're used to having things be new minus old over old times 100, right? That's our typical formula for percentage change. We're not doing that anymore. That's wrong. So the new way that we're doing percentage changes is we're doing new minus old over what's called the midpoint, new plus old divided by 2. And so think about, if we're talking about the elasticity between the prices of 10 and 20. One way, if you're going to 10 to 20, that's a 200% increase. If you're going from 20 to 10, that's a 50%, right? So we want it to be bidirectional. So, you know, a price change that's increasing and a price change that's decreasing is going to have the same elasticity. So in order to do that, instead of having it be over the old value, we just have it be over the average of the two values in the denominator. So this is what's called the midpoint formula for percentage averages. So let's think about what does it mean if this value is greater than 1. What's that mean? So let's unpack this formula. So so that means that the percentage change in the quantity demanded divided by the percentage change in the price is greater than 1. So another way that we can restate this, right? We can multiply both sides by percentage change in quantity demanded. Or sorry, percentage change in price. And we end up finding out that if the elasticity is greater than 1, that means that our percentage change in the quantity is greater than our percentage change in the price. So that means that if I had, let's say, some sort of 10% increase in the price, I would expect my percentage increase in the quantity demanded, or sorry, percentage change in quantity demanded, so it's not going to be an increase because of law of demand, right? I'd expect this to be something like, 20%, right? It has to be greater than. So, but it could be anything. This could be 30%. This could be 11%. It just couldn't be something like 9%, right? So that's what this value is telling me. It's telling me that the relationship between the responsiveness of the demand is greater than the responsiveness to the price. And so this is what we call elastic. Right? So elastic, like a rubber band, right? It stretches a lot. Now compare this to a situation where what if the elasticity of demand was less than 1? So once again, we unpack it and we say, well, the percentage change in the quantity demanded over the percentage change in the price is less than 1. I can also do my little loop-de-loop guy here. I can say 1 over 1, and then I can multiply that guy by that guy, that guy by that guy. So we end up with percentage change in price times 1 is equal to percentage, or sorry, not equal, it's less than. Got to make sure to keep that inequality in there. Is equal to percentage change in quantity demanded times 1. Anything times 1 is just itself, so we end up with percentage change in the price is less than the percentage change in the quantity demanded. So this means that if I had some sort of 10% increase in the price, I would expect, oh wait, I did this wrong. Math. Let's just stick to the way I did it before. I flipped the inequality. It messed the whole thing up. Well, now we have a chance to do it all over again. Woohoo! All right, slower this time. Percentage change quantity demanded over percentage change in price is less than 1. We will multiply both sides by the percentage change in the price. That's going to cancel, annihilate that, and we end up with a So this means that if there's some sort of 10% increase in my percentage change in the price, my consumers are not as responsive, meaning that the change in the quantity demanded is only going to be something like a 6%, because it has to follow this inequality, right? So it's got to be less than that 10%. So this is what we call inelastic. And one of the ways that we remember the kind of good that inelastic is we know that it rhymes with, or it's not rhyme, but it's another mnemonic, an acrostic. It's insulin, right? Inelastic, insulin. They both start with the same letter. If you're diabetic and you need insulin, it doesn't matter how much the price increases. You're not going to be that responsive to any sort of hike in price because you need it in order to live. So you don't have a lot of responsiveness to the price. So we know that this is always actually going to be a negative number. So because of the law of demand, there's always always an inverse relationship between price and quantity demanded. So the actual elasticity of demand is always negative, but we ignore the minus sign and use absolute values of both the percentage changes. Absolute, not absolute. All right, so let's go ahead and do some practice. So back of the book, number 2, so page 106. This is just the questions part of chapter 4, and we're going to do number 2. So it tells us to graph the accompanying data, which I will reproduce for you below. So we're told that at $5, 1 unit is demanded. At $4, 2 units. At $3, 3 units. You get the point. It's pretty easy setup here. And so we're asked, what is the price elasticity for each one of these possible $1 price changes? And what can you conclude about the relationship? So, okay, one at a time. So the first one, A. What's the elasticity of demand at the price shift from 5 to 4, from 4 to 3, from 3 to 2, and from 2 to 1. So let's go ahead on your own, go calculate what are the price elasticities of demand for all of these different demand points. We can graph them real quickly. All right, let's get going. All right, what do we get for the elasticity of demand when we go from 5 to 4, Gavin? Matthew.
We're sitting here together.
Ethan.
I'm still working on it. I'm not sure if I'm doing it right. I don't know yet.
Okay, so let's work on it together. Okay, so what's our formula? We've got percentage change in the quantity demanded in the numerator and percentage change in price in the denominator. And for our purposes here, the only thing we care about are the 5 and the 4. The rest of them don't matter, just for this first part. And so essentially we have 2 points, right? We have a point that's 1 quantity and $5, if we want to do the old XY coordinate pair, right? And we've got 2 quantity and $4. So you can think about this as, this is Q1, that's Q2, this is P1, and that's P2. So unpacking each one of these, the percentage change in the quantity demanded, we know is a fraction in and of itself, right? It's the new minus old, so it's going to be the Q2 minus the Q1 all over Q2 plus Q1 divided by 2. On the denominator, we've got P2 minus P1 divided by P2 plus P1 over 2. So, bringing this over here, let's start to plug some values in. What's Q2? 2. Q1 is 1. Q2. Q1. What's P2? 4. What's P1? 5. So we're clear on how we got to this part now? What's 2 minus 1? 1. Divided by 3 over 2, 1.5. 4 minus 5, negative 1. Divided by 9 over 2, 4.5. So this ends up giving us negative 3. And then we always take the absolute value of that. So we end up with an elasticity of 3. Now let's go ahead and do that for the next values. Or actually, let's just go and do it from 2 to 1. Well, that's going to be too similar. Let's do it from 3 to 2. So again, how can we think of this? We can think of this as pairs, right? We have a pair here that's $3, for $2. So this is my Q1. This is my, P1. This is my Q2, and this is my P2. So then we just plug and chug. So elasticity of demand is equal to quantity 2 minus quantity 1 over quantity 2 plus quantity 1 over 2. Divided by P2 minus P1 over P2 plus P1 over 2. So what's my second quantity? 4. My first quantity, 3. 4 plus 3 is 7. 7 divided by 2 is 3.5. What's my second price? 2. What's my first price? 3. Not 1. I'm going to divide it by 2 plus 3 over 2. So 2.5. So we end up with 1 over 3.5 over negative 1 over 2.5. And this ends up being 0.3 repeating. So it's really just a matter of identifying those pairs, selecting what's Q1 and Q2. You can't see that very well at all up there, can you? Sorry about that. Selecting those pairs, identifying what's Q1 and Q2, what's P1 and P2, and then just plugging it into that percentage change formula. So what I'll do is I will alter the homeworks so that you guys have a lot more practice on this, and then I'll move chapter 5 to next week, since we're not going to get there. But moving on, talk about supply. So this concept is just this same exact thing with supply. Instead of percentage change in the quantity demanded, though, now it's the quantity supplied and how that responds to a percentage change in the price. And so why does this happen? So this is when there's shifting of resources between alternate uses. So it relates to the flexibility of the producer. And so really, in order to discuss the elasticity of supply, we have to start to discuss what time means in economics. So time periods have special certain meanings in economics, right? It's one of those jargon things that I told you about. So the first thing that we're going to talk about is the market period. So the market period is so short that the supply is inelastic. So, you know, the crop's already been planted, or even the produce is already on the truck, right? The farmer's already on his way to the market, to the farmer's market to sell the produce. It's impossible to adjust resources, quantity supplied. And, you know, during the market period, you know, you'll take 10 cents, right? Because you don't want something to spoil. So we talked about that before, but especially with perishable items, you may want to take a loss on things just because half a loaf's better than none. Short run. So this is more elastic than the market period. And it depends on the producer ability to respond to price changes. So, industrial producers, right, they have some flexibility. Would be, having workers work overtime. Or, bringing in an extra shift. Bringing in a third shift. The farm example, we can adjust what day, what goes on the truck each day based on what he observed in the market that week. So they could be like, all right, I'm going to put more corn in and less squash, right? Our long run supply is the most elastic. So it's more adjustments can be made over time, and the quantity supplied can be changed to, relatively small changes in price. So, our example here is, the producer, so the producer has time to build a new plant. Farmer has time can plant different crops or expand their land. All right, last couple things. I know I'm kind of cramming a lot in here, but income elasticity of demand. We've already talked about this a little bit when we talked about normal goods and inferior goods. So this is usually represented E with a I on it. And so this, again, I told you the key is that the quantity demanded is always on the top. The other key to it is that the thing that's on the bottom is always some sort of price. So this is the percentage change in your income, which if you think about it is the price of your hourly work, right? It's the price of your week, it's the price of your year. So income elasticity of demand is talking about how much does the quantity of something change as your income increases. And so we know that if it's greater than 1, if your income increases, and that means that, if it's greater than 0, if your income increases and you buy more of something, then we know that that's what? A normal good. However, if the income elasticity is less than 0, right? So this, we don't take the absolute value of this. This absolutely can be negative. This means that as my income increases, I'm going to buy less. And so this is what we call a inferior good. Ramen noodles, bus rides, store brand toilet paper, right? All that jazz. All right, I will alter your connect to have a lot more just like math kind of review stuff and get rid of cross elasticity of demand. That's what we'll start in class on Tuesday. Again, no class on Thursday. Have a great week, guys and girls. So we'll start on Tuesday.